Welcome students to another video in maths, and today we start the chapter triangles. In this chapter we will be studying congruence of triangles. Congruence of triangles. Now this congruence, what do we mean by this word congruence or congruent triangles? That is, congruent triangles, suppose you have two triangles. Okay, these two triangles, if they are such that when you place one over the other, it just covers the first triangle, then we say these two triangles are congruent. That is, if the triangles are congruent, they are of or they have same sides, same angles, so that or they are of the same shape, same size. They are congruent triangles. I have suppose this triangle and this one. Are they congruent? No, because if you place this over the other, this triangle, will it cover this full triangle exactly? No. So these two are not congruent. Similarly, we can have congruent circles. Two circles will be congruent when? When they have the same radius. Similarly, we can have rectangles. These two rectangles will be congruent when? When this side is equal to this side is equal to this side. The two figures will be congruent. So congruent basically means exactly the same size and shape as the first one. The figures are congruent. Now if this sign represents congruent. Okay, now here in this chapter we will be dealing with congruence of triangles. Now suppose I have this two triangles, or for one triangle, you can see for this triangle, a triangle has three sides and three angles. We call them parts of the triangle. So a triangle has 6 parts, 3 sides and 3 angles. Now, for two triangles to be congruent, do we need to see whether all the 3 sides of both the triangles are equal, all the 3 angles of both the triangles are equal? No, we have some minimum requirement. Now, what are they? The first criteria for congruence of triangles is S rule. S stands for side. So side, side, side. That means if you have two triangles, say triangle ABC, triangle PQR. ABC and PQR are two triangles such that AB is equal to PQ, this side BC is equal to QR, and this side AC is equal to PR. That is, all the three sides of the first triangle are equal to that of the second triangle. Then we say triangle ABC congruent to triangle PQR. Clear all of you? Triangle ABC congruent to triangle PQR. Okay. The second rule is SAS, side angle side. Now what does this mean? Again, you have two triangles. say ABC and PQR. Two sides. Suppose this AB is equal to PQ. Another side BC is equal to QR. And what about the angle? Now see here, this angle is between the sides. Angle is between the two sides. We call it included angle. So which one is the included angle here? Angle between the two equal sides. This angle must be equal to this angle. Only then these two triangles will be congruent. So what is SAS? Two sides and the included angle of one triangle must be equal to that of the other. Then the two triangles are congruent. Now suppose in this case, if you have, this is triangle ABC and PQR. Suppose AB is equal to PQ, BC is equal to QR, and suppose this angle C is equal to angle R. Here also we have two sides and one angle, but here the triangles will not be congruent. Not congruent. Why not congruent? Because this angle is not between the two equal sides. Okay, children. So, for two triangles to be congruent, SAS rule, two equal sides and the angle between the equal sides, they have to be equal, then the triangles are congruent. Clear this second rule? Okay. Next we have the third one. Third one is angle side angle. Again angle side angle. So again we take two triangles. Two angles and the side between the equal angles. So suppose this angle is equal to angle Q, angle C is equal to angle R, and side, which is the side between the two angles? This one, BC equal to QR. If this happens, then the triangles are congruent. These two triangles are congruent. Now suppose I take ABC and PQR, two angles be equal to angle Q, angle C is equal to angle R, and suppose I say AB is equal to QR. Now, will the two triangles be congruent? Let us find out. Now, what happens here? When we talked about this one, the two angles are equal to these two angles. Then, what about the third angle? Will the third angles be equal? Will angle A be equal to angle P? Yes. If two angles of a triangle are equal, the third angle will automatically be equal. So here you see, in this case, we have two angles equal. So this angle A must be equal to angle P, isn't it? So now if we take any side, if we have these two sides equal, this is again side between these two angles. Okay, so in this case also the triangles are congruent. Why? Because if two angles of a triangle are congruent, two angles are equal, the third angle will always be equal. Therefore, this rule we can also write as AAS. Not necessarily the included side. Any two angles and any one side must be equal. Then the triangles are congruent. Clear? Okay. Next we see RHS rule. Now what is RHS? RHS, R stands for right angle, H is hypotenuse, S is side, and this rule applies only for right angled triangles. So suppose we have again two triangles, right triangles A, B, C, and P, Q, R. These are the right angles. Right angles 90, they are equal. H, hypotenuse. Which one is the hypotenuse? AC. And which is the hypotenuse here? PR. If AC is equal to PR and side, any one side, this is one side AB and this is the second side BC. Any one side, suppose this BC is equal to QR, then the two triangles are congruent. This is RHS rule, applicable only for right angled triangles. So what you found is, to show two triangles to be congruent, you need to show minimum three parts to be equal. Then the triangles are congruent. And what are those? It can be all the three sides. It can be two sides and the included angle, that is angle between the two equal sides. It can be two angles and the side between them, or any two angles and one side, or it can be RHS. That is, if you can show, if the triangles are right triangle, hypotenuse equal and one side equal, then the triangles are congruent. So these are the criteria for showing two triangles to be congruent. Okay children, so thank you, this much for today.